So I go mainly to the big customers that we have. I work with 3 SEs around the region. Me for Australia, New Zealand, a guy for Japan, and a guy for Korea. Our biggest customer in the region, including Spark, is Yahoo Japan. So Yahoo Japan got 5,000 cluster right now, and it's because of our biggest cluster in the world. All the R&D is now happening with Yahoo Japan. The next comes SK Telecom in Korea with 3,500 clusters, and of course after that comes Telstra. So these are kind of the 3 biggest customers for us. And before I wanted to start on Spark directly, I've seen a lot of people wanted to know more about getting data in our systems. And when I'm saying how we get and ingest data, we're not talking about structured systems like Hive or structured system like SQL Server and how do I move data from a table to another. We're talking about the real data that we want to do the analysis on, whether it's text data, security data, logs data, that sort of stuff. And this is when we worked with a product, and I'll get to show you exactly what the product is. But if you look at it, what is our biggest problem right now before we get to the data science bit is how do I get all the data in one place at the right time so I can start working on an algorithm or start working on a certain ML pipeline or any sort of discovery on it. We have all of that sort of data running something, whether it's social media, whether it's files coming from your security logs, whether it's any sort of unstructured data. And we have the way to process it, whether we want to process it with Spark, with Hadoop, or even with Storm, and eventually we want to store it. But where does that piece fit in? How do we get the data properly in the right place? With that, I don't need to be a developer. I don't need, for every time I need to get data and I have to write a Storm processor and get Kafka in and do all of that complicated stuff for a single use case, and then I'll have to add more, and then I'll have to maintain it. And this is something people usually care about. Every time they want to ingest data from point A to point B, they have to worry about all that sort of stuff. What is the protocol am I connecting to? I don't know, HTTP logs or an FTP or the activity, what is the format of it, schema, priority, side of event, and that sort of stuff. And so it kind of like end up like this eventually with the amount of sources. Every time you add a new source, the first 3 sources are easy. After the 3rd source, it starts getting really complicated. So it's not about how quickly we move the data, it's how can we tune it and how can we put it in operation, especially in production. And that what makes the difference. So yeah, let me skip that. So what happened? We and the NSA in the US open sourced a very great product, and this is when actually governments are start being part of this ecosystem, the open source system. And they said, okay, this product, this is what we're using for whatever you're using, but we want the people to start working on it and adopt it, and we want to see more stuff add on the open source community on it. So what was it? It was Apache Nifi. Nifi stands for Niagara Falls, by the way. So we acquired the company who started Nifi at the NSA, which is Onyar. And we, of course, we continued that we moved the source to an Apache foundation. So now it's Apache Nifi, and it's completely open source. So what does open source mean? It means that you, as somebody who want to develop a new processor, can put it there, and somebody else can start using it directly from it. So how does it look like? I'm going to go through a demo later on, but it's mainly boxes you can drop. And every box is a processor. And we'll show you kind of like a manufacturing use case where they have 5 different log generators, and we want to grab an FTP and an HTTP and different sources and put it together and throw it in HDFS in less than 5 minutes. So we create a workflow, and the beauty of it, because this is a workflow, I can always go back and fix whatever I want. I want to split it, I want to compress it, I want to encrypt it. And the main features, kind of the one on the left, these are like the most important ones, specifically the data buffering. And this is why we used to have message queuing, because if data flows super fast, I need some sort of back pressure where I can save it somewhere until the consumers start consuming my data. So we work with back pressures. There is priority. A lot of customers care about the order of the data. If X comes before Y or Y comes before X, because it will mean something for me. If you're doing, I don't know, even a recommender system, you would want to see how the data is coming in order. If I want to show you something here quickly on that, I'll have this up and running. So I'll even zoom a little bit in so you can see it. So it's easy as just picking a processor and dragging a processor. So, and usually the use case is, let's say I have, I don't know, I'm in a manufacturing plant, for example, and I'm getting data from 3 different sources. So what I need, or even if I have data sitting on AWS as well, all what I have to say is get. And anything after get is a processor, is a source that you can connect to. So let's say I do have a directory that some sort of machine throw files at, and I want to make sure I grab that. I'll put an add, and I'll go and right click and configure that, and I'll go to the properties, and I'll say, okay, I want you to get everything out of my NAS machine that has a log server or a logs directory in it. You can do file filtering, you can do a lot of stuff, you can do scheduling, you want that in real time, you want that cron-based, timer-driven, what is the priority for it, does it expire at some stage, so if I don't get the data in a certain time, should I just forget about it or not? Let's do another processor. Let's say I want to get data from HTTP, and this is when, for example, you click streaming stuff could be, or you've got an HTTP server that's throwing something out. You put a get HTTP, you add it here, and let's say the last processor, I don't know, you tell me. So there's get, if we go through it, there's file, FTP, HTTP, message queue, Kafka, Mongo, Solar, SQS that connects to AWS. Twitter, so let's say I have, I don't know, some bucket of an S3 that I want to grab. So once we have all of these sources, all what I need now is to do some action on it. So let's say I want to make sure I compress the data, for example, first. Or I want to scan the content. So I'll put another processor here, and I'll say scan content. So once I add that, I just need to configure it. What do I want to scan for? So let's say I'm running something like I want to make sure I don't get any blog files with a word edit, for example, or warning. I want to make sure I capture anything that includes these 2 words. So I'll put the get content here, and I'll create the relationship by simply dragging the files, add, dragging the files, add, and again dragging the files here, add. And you can go through the relationship and you can configure that whether you want to have an order like first in, first out, for example. What is the back pressure? We set up back pressure based on the memory we have in the Nifi server, for example. So the more memory you have, the more buffer you can keep in that memory. So what happens after scanning content? And this is where you use the opposite for get, which is going to be put. So you can put an email as a notification to somebody that, okay, this thing was passed by, you might want to see it. Or you can put it as a file in somewhere in a directory or back into AWS. Or in my case, I want to put it in HDFS in Hadoop. And what I'll do, I'll just create a relationship based on match. So anything gets scanned and matched the words that I had in the scan content, I can just say I've matched. And again, I can set the back pressure if I want. And I go to HDFS, and I'll add which directory in Hadoop it should go to. So, as simple as that, we have a whole workflow in less than 5 minutes that can run the whole ingestion for specific use case that you're using. Do you pay for that? As I said, Apache Nifi is open source. You can start using it right now. When you want to get enterprise support on it, let us know. So we call that HDF, Hortonworks DataFlow, which is based completely on Apache Nifi. These processors are the open source part, so you will see open source community putting new processor every time. So whenever you think about a new processor, you can either go and create it and push it back to the source, so everybody can use it, or you can just use whatever we have right now. You can create templates, there's a lot of stuff. I thought this is kind of like a cool tool. A lot of people, even not our customers, are looking at it because it doesn't matter, you don't have to have Hortonworks to use HDF. You can, if you're running already on, I don't know, Cloudera or Bar, or even without Hadoop at all, you can have HDF running and we can still support you on without the need for Hadoop to be part of it. So because we're kind of like the only one who do some cool stuff like that. So I guess that's it for Nifi. And I'll jump. Okay, now let's jump on the Spark stuff a little bit. Who did work with Spark before? All right, 3, 4. Who did work on Hadoop before? A little bit more, great. Who comes from a database background? Yeah, me too. Who comes from a data science and algorithms background? Nice, that's in here. Great, so I'll be focusing a lot on the data science, but I'll be also focusing on the Spark as itself. Because a lot of people here, we're kind of going to be mixed slides. Some of them will be 101, some of them will be 102. So if you don't get something, ask me later on it and I'm happy to answer. So when people say Spark, what is Spark? And at some stage we start getting questions, oh, is Spark replacing Hadoop? And we're like, oh, they're two different things. There's nothing replacing anything. Yeah, Spark is replacing MapReduce, but not the Hadoop is a platform. It's like Spark replacing Linux. They're two different things. Spark runs on Linux, Spark runs on Yarn. Spark needs a scheduler to run, and we'll talk about the scheduling later. So when we say Apache Spark is not a single product. Apache Spark is a platform of stuff. And the power of Spark, actually, when you start using these platforms together, and we'll talk about how we use it. But this is how Spark started. A lot of these things were in alpha, and then they graduated to beta, and now they're in production. So the Apache Spark as an engine, as a core engine, this is how the whole thing started, and then they start plugging components on top of that. For example, using SQL, Spark SQL on top of Apache Spark Core, and now I want to use Spark Streaming as well on top of Spark. Machine Learning, GraphX, and R as well, since 1.4 R is supported on Spark. So if we look at, if you're, now this is more like a 102 slide. If you're already doing work with Spark, and I had a question from John just a minute ago. We always tell people, if you're doing any POC or testing, and you're working directly with a GitHub, go to the master branch and go to the latest, because anything that might be a bug or something is probably fixed over there in the latest in the master. If you're doing anything in production, you're better off. So if you're using Hadoop, you better go to a Hadoop vendor and see what is the latest that we support from a Hadoop perspective. Otherwise, if you're doing just a Spark production on Mesos, for example, you always want to grab the latest on the branch. So 1.5 or 1.5.1. So whatever in the branch, just go to the latest. Whatever for POC and testing, go to the master and go to the latest. That's just to avoid issues that you might have because of the code or something. So what was the 2015 direction for Spark? That was mainly last year. It was mainly concentrating on the data science part, and this is when we see the ML. This is when we saw the auto Spark. And of course the platform API, growing the ecosystem around Spark, because without an ecosystem, without being able to integrate my stuff, let's say my databases or my JDBC drivers or AWS and that sort of stuff, I won't be able to use Spark the way I want. So the most impressive things or big things that happened in Spark in the last year, I would say 1.3 was big and 1.4 was big. 1.5 had a lot of new things, and 1.6 had, we'll talk about 1.6 later. But this is kind of like the milestones for Spark this year. The R support on 1.4, yes, until now R is not fully supported, but a lot of, probably a lot of algorithms on it now is being supported. The ORC file format, and this is something Hortonworks came up with. It's kind of like similar to Parquet. So you have Parquet and there's Orc and Avro. And the three of them are supported. We would recommend using Orc when you're working with Hive, for example. Because if you want Hive if you want to optimize Hive for speed and have the best compression, you can choose what kind of compression you want to have in Orc. We would use the Orc. Other than that, if you're still working with Parquet, that's completely fine, and you're not using that. The data frame was a big one. For the data science, you understand what a data frame is. It's the same as a frame or a data frame in Python or R. For the SQL guys, think of a data frame as a table. It's just a tabular representation of data. So converting a text file to a tabular format in order for me to make sense out of the data much easier. And the ML pipelines as well graduated from. So here you would see, for example, the running time for the different. So before data frame, we were working mainly with what we call RDD. We're going to get to the RDD. And in the RDD, if you're using Scala, you would have a better performance over Python. But with data frame, it doesn't matter anymore because Scala and Python will get the same sort of speed. If one you're not following, we're going to talk about data frame just in a second. So how do we see Spark in the Hadoop world? We see most of the users of Spark are mainly in the data science part and a little bit on the SQL part. We've seen a lot of, it depends on how big is your cluster eventually and how big is the data set you're working with in your queries. So the big queries were usually more stable in time. And when I'm talking about big queries, I'm talking about data sets beyond 1 terabyte of size. So Hive was running more smoothly with the bigger data sets, and there was no much of performance difference, and that was out of testing SK Telecom have done, and they published it. However, most of the data discovery stuff doesn't happen on a 1 terabyte data set. It happens on a small data set, and once you find the right thing, you just apply it on the bigger data set. And Spark becomes faster, as long as you have the memory to do that Spark efficiently. Okay, so if you look at what happened in the past 15 years, the MapReduce paper was leaked out of Google, and the 2004 comes. The first MapReduce paper was leaked. Yahoo worked on Hadoop in 2006, and they were the first to use it. So we had the first Hadoop Summit in 2008. The first Spark paper out of Berkeley University was in 2010, and Apache Spark was a top-level project in 2014. So between 2014 and now, it's like a year and a month. There's a lot of stuff happening. Kind of like 2 years now. There's a lot of stuff happening. Like even production systems now, since the last 10 years, didn't get to a Spark. So why people have been talking about Spark a lot? Why did we need Spark from the beginning? Mainly because the most important and most expensive operation we do in the data center is I/O, disk I/O movement. This is when the data, the instruction comes from the processor, goes to the motherboard, down to the cable, down to my disk, and disk has to spin and come back for the instruction with the information. So what we always need to try, and this is when we start seeing SSDs and PCI SSDs, but if we don't have the data in memory, this is the optimal thing. And I have the way to properly put it in memory. There's no proper caching, and I have different data access layers. So I'll have a data set that I want to use it with SQL. Now I have a CSV data set. I got to open it with the R, for example. I have another data set that needs another product to open it with. This is when Spark came and said, okay, how about we give you the same access to all kind of data, and if you're on R, you can use R on Spark and read that data. If you're working with Python, you can use Python on Spark and read that data and do whatever you want on it. If you're a SQL guy, you can still use Spark as well and do SQL on it. And when you're working with a Hadoop vendor, for example, we give you the security to make sure that the right people can access that, and you don't want, at the end of the day, anybody to jump on a cluster and utilize the 1 terabyte memory that you have for a single job. So what was the solution? Was the RDD, the resilient distributed data set. And this is when you load a data set and you start an action on it, the data comes up to the memory, and everything happens out of the memory. So comparing to MapReduce, this is what happened. And that way, Spark kills MapReduce from day one. Every time we needed to do something in iteration, for example, the first read is always going to be from disk because I got to move that data from somewhere to the memory. So it's kind of like the first iteration is going to look the same. But once I move to the next iteration, this is when I start reading. I already have the data in memory. I can read the data directly from memory. Well, MapReduce doesn't care. They'll have to go back to the disk and reread it again. If I'm doing a third iteration, I'll just go and grab the delta from disk because I have everything else is in memory. Well, MapReduce has to go and grab the whole data set again and put it up there. So therefore, from day one, Spark was able to do 200 to 300% faster performance than Spark. So just quickly on the architecture for people to see how it works. Whenever you submit a job on Spark, the first thing we do have something called a Spark driver, and that usually you nominate that to be one of the nodes. And immediately the driver picks up the request. And in this use case here, I'm loading a text file from HDFS that's going to be converted to RDB. And I'm doing a filter, anything starts with error, and I'm mapping it, and then I'm caching it, then I'm doing a count on anything contains food. So what happens is I have the data set on different machines, because in HDFS, the data set will be set of blocks, and the blocks will be all across the cluster. The driver will send a request, the data will be fetched, and it will start sending the result from every worker back to the driver. So every worker node will cache the data set that it has it up to its memory, and everything, all the counting is happening by the worker doing that computation on its node, and comes back to the result to the driver, and then give you the full text search back, for example. So if we look at the resource scheduling, and this is a big topic, because once you start working with Spark on production, you're gonna face issues, especially with resource scheduling, because it's a big topic. How I'm gonna allocate the memory? Am I gonna allow any job to take all of the memory that I have? Who's gonna be authorized to do what? So this is when you have something like Yarn, for example. So you have two options from day one. You'll have either doing it on Yarn or in Mesos. We see a lot of Mesos installation and siloed. If your model is a siloed data, you don't need something like Hadoop here. Let's say a very specific research center that only have one use case and one kind of data, and you don't need to share the data across other workloads. Usually upload Mesos. And if you're an enterprise where you do have multiple use cases and multiple data sets, and you want to use them across different tools, like SQL, for example, you want to stay with Hadoop, because you can have these tools within the system. You don't have to move the data from that silo to the other silo to the third silo. So yeah, eventually you'll turn on whatever tools you want, including Spark, on top of Yarn, and orchestrate everything using Yarn. So how do you deploy? You got three options. You start, if you're just testing things out, you can download it on your laptop. Just go to your GitHub, download Spark, and run it immediately. So that's standalone, no resource scheduling, all happening on one node, your laptop. Your second option would be Hadoop. You can build it yourself. You can go to Apache, download the Hadoop on Apache, and download the Spark and build it yourself. You can go to Hortonworks, download the sandbox. Everything is pre-built in on it, and with Yarn. Or you can build a Mesos cluster. So you get a cluster, download Mesos, configure Mesos, and put Yarn on top of it. So it's completely up to you how you start. Usually you probably want to need to build Spark if you're going for a custom build, a custom version of Hadoop or something like that. You'll have the option to do it with maybe Gradle or SVG. And you have to choose whether you want to use the Hive first server with that or not, and that's mean I'm going to have access to Hive if I have Hive in the first place. So whenever you log into Spark the first time, by the way, a lot of people go, oh, that is this what I get? Yeah, so this is how Spark looks like. At the end of the day, you control it with the command line. The command line will give you options. It will give you Scala, you can work with SQL right away, but the SQL interface is pretty new. Before 1.4, I guess, we didn't have a SQL interface. Everything was Scala. We had to do everything on Scala. So if you're a Scala developer, you are in the perfect job, the perfect spot. If you're not, you're going to learn until SQL is out, and it made a lot of people like to be here. So now, we're going to talk about notebooks to eliminate the ugly command line, because I like command lines, but not when I'm working with Spark. So this is, for example, the Spark monitoring, the UI monitor that tells you what's running, where it's running it, which nodes are working or not. So first thing we do with Spark, after we install it, you're gonna run Spark. So once Spark runs, it creates something called a Spark context. The Spark context, you run usually anything, any data in the Spark context is shareable across the whole cluster. So a Spark context is mainly one command line you run, and it spins up the Spark context on the cluster. And you're allowed to have one Spark context per JVM. And this is how you create the arguments and the data frames and that sort of stuff. So how do I load the data set? There's a lot of options. So the easiest one is just Spark context.txt file and point it to the text file that you're trying to read data from. I'm going to go through more demo through the notebooks, but these are kind of like the basic operation using Scala, not SQL. SQL is just direct SQL. And there's a cool thing happened in 1.6 that actually eliminated the need for registering a table every time we're loading data. The Spark SQL. Spark SQL is a subset, is Hive on Hive code. So if you go to the Hive source code on Apache, Hive is over 1.5 million line of code. Well, Spark SQL is like 200-ish thousand line. So how did they have all that capability? Because it was built on Hive. Instead of rebuilding everything, they said, okay, Hive is a very solid SQL engine. I'm going to take a query language and build Spark using the Spark's core engine instead of the Hive engine. So how did that look like? So this is the motivation. Why did they do it? Hive is great, but Hadoop execution. And this is when Hive was mainly using MapReduce. A lot of things change now. Hive is using tests now and other IPs, so things have changed. But Hive is the metastore. Spark doesn't store data. This is what you're going to understand. You're going to store the data somewhere. It's going to be HDFS. It's going to be on the file somewhere, or it's going to be in Hive. So what happened is that was Hive. If you're a SQL person, you understand that immediately. Whenever you have a request, you go to a CLI, to a JDBC, to a driver. It will do the SQL parsing for whatever SQL statement you've done. You go to the metastore to grab the table that you query. We'll go to a query optimizer, do a physical plan, and execute it. And in the old times, it used to be done on MapReduce, which was very slow in order to execute that. So what Spark have done, they said, okay, you know what, we're going to keep the same thing, except that I don't want to use the MapReduce part anymore, and I want to use the Spark core engine. And that means anytime, and I want to have a cache manager in every node. So that means every time I'm doing a query, actually the data is being saved in the cache. And of course, you do have the option to remove it from the cache or delete it or not allow it to stay in the cache for a long time. But this is what drove the whole thing. This is what made it a great product. The plugins changed the way people interact with it. Without this, Spark would never got to what it got right now. And it's mainly because how many of us have databases? Everybody. 99% of it. So having a JDBC connection is vital. That means whatever database I have, and usually in other advanced meetups we used to set like 3-4 different databases. And how many people worry about something called a federated query? Okay, so this is something we hear every day in the market. Oh, I need federated query. Oh, what do you mean? That means I have 4 or 5 different databases and I want to do a single query to grab the data from all of these databases at once. because I don't want to access all of these systems to do it. You have a decision to make. You can build a report, of course, but from a discovery point, you need to have a single query engine to access all of your databases. And Spark came as the solution because I can get the same tables, like I have table X table, Y table, Z on 4 or 5 different databases. I can connect to a JDBC and bring them all into my memory, and I can run the discovery in memory for all of these tables that sits virtually on different databases. And whenever I'm happy with the result, I can flush the result on HDFS, on a text file, or whatever the output will be. So JDBC is number one. JSON files. 50%, I would say at least, of the audience here manage or deal with JSON files somehow. So that was a great thing. I don't have to convert JSON file to a table or to any structure that Spark has to understand first, because Spark can read JSON file directly, and you can immediately convert them back to whatever you want. We talked about Parquet, we talked about ORC. If you already have Hive running, and most of the time we run Hive and Spark together, the SQL all the data scientists will be using Spark to access Hive and get the tables from it whenever they need to match unstructured data with structured data, and we keep Hive for the compliant, kind of like an OLAP sort of platform for the database administrators and the reports to be running on time. HDFS, S3, you can load data from S3 directly, Postgres, MySQL. This is like kind of a snippet of what's actually there. If you go to packages.spark.com, I guess, there's a lot of more drivers I can see. And it's mainly covering the external ones, because the external ones are not developed by the Spark guys, it's developed by the commerce. So, so Amazon, the Redshift, for example, Apache Edge-based Elasticsearch, if you're using any Elastic. So there's a lot of packages that you can use for that. So that was actually a use case. We've done it in Victoria based on that we were showing the water consumption in every suburb and how it looks like. So again, I'll go through the demos eventually. So we talked about data frame. It's a representation of some sort of unstructured files into a structured world. Now, in 1.6, that's not on the present, but in 1.6, Spark came up with the data set. So there's a data frame. So they started, just to avoid the confusion, they started with an RDD, and everybody now is using a data frame, which is the next generation, and now they came up with a data set. How does that differ from what you have to understand that if you're working with Scala, you might want to start using the data set instead of data frame. How many of here work with Scala? 1, 2, 3. Okay. So the data set performance using Scala is faster than anything else. Because once they want to do it in Python or whatever, or R, the interpretation from Scala to the other languages is a big overhead, and it becomes the same whether you're using data frame or a data set. So if you're a Scala programmer and you're working with Spark, work with a data set. If you're doing anything else, work with a data frame, you're going to get the same performance exactly. How do we write data frames? For people who are interested on the code, you just actually create a data frame by, what's creating data frame is reading that file, and there's a kind of like .2df which creates a data frame out of it. And you can show it. The data frame has great functions. You don't have to do print line dot open a bracket the data set itself. You can just say df.show, df.print schema. You can even do select. So this is not ANSI SQL, but it's kind of like similar. So it's kind of like explaining syntax manually. I don't have to go through it. We'll go to the SQL stuff in a second and see it. I'll skip the code for now because I'm going to show you it in the notebook. That's when we talked about the difference between the data set, the data frame between Python and Scala. Because if you're using a data frame, the performance doesn't differ at all. Tungsten. Now, because Spark is super fast, and the JVM was created 15 years ago, there was a lot of limitation. The JVM wasn't built at the time when we had 10 gig connectivity or that much of memory that we can have. So the JVM start because you run a Spark context inside a JVM, and the limitation now is not the machine, not the hardware, it's the JVM. And the only way to get around it is making Spark managing the memory directly on the machine rather than going through the JVM every time I need to talk to the memory. So Project Tungsten is all about moving one step beyond the JVM and try at least some of the components will be moving away from the JVM just to make sure I can talk to my data sets quicker and faster by talking to the hardware directly rather than going through software. So and then it's the code generation and the JVM limitation were the issue. So that's probably exactly what I mentioned, that the hardware was improved and that format. All right, so we talked about 1.4 being one of the milestones of Spark. We talked about the Spark R being there, the Python 3, the org format, the cube functionalities for SQL. If you work with any cubing, Spark SQL can do that. And from a Hortonworks perspective, a lot of people ask, we're using Hortonworks, but you're not on the latest version. We can't always be on the latest version. We always one version behind in a GA, because if you need support, we need to test stuff before we put it under our belt of support, because what we sell is eventually support. If we're not good at it, we better close off. So that's why you see us always one version behind. However, we're kind of here right now. So we do have 1.6 as a tech preview now, and when we say tech preview, that means it's not supported. So with that being in 1.5, how many of you are familiar with Ambari? Okay, we're going to see Ambari, correct. All right. More about, let's skip that. Okay, Zeppelin. So, what is Zeppelin? Zeppelin is, anybody worked with IPython before? Jupyter? Yeah, so with that science topic. Okay, so this is cool. Zeppelin is your way for, especially for the SQL background people, to get into that sort of stuff, because Zeppelin is cool even for SQL. And most of the stuff you're gonna see here is in SQL. This is a data set that we created out of the healthcare expenditure in Australia, how much we're spending on hospitals and how much we're spending on machinery in hospitals and doctors. But it's very cool. So what is a notebook? A notebook is a way to preserve my code, preserve my SQL statements, preserve my results, and share it with others. So you wouldn't have to go to command line, create a SQL query to get some data in a very bad looking output, and then it goes away with the command line. So a notebook is a great way to preserve the data, and on top of that, visualize it in a nice way, and you can export it out to HTTP or to some of your colleagues or anything like that. So it is a web-based. It supports multiple languages in the back. What does that mean? If you want to work with Python, you work with Python. If you want to work with Scala, you work with Scala. SQL, Hive query language if you want. If you're a Pivotal user, they have a database called Hawk. You can use Hawk as well as a Postgres driver. So you can do everything on that single page. And that brings like the whole exploration thing that you're doing in your company from different people could be on one page, and you can share it with each other. And you can bring out pretty cool results. We're looking at working with Zeppelin with a team and support it hopefully during this year, which is a great step. You'll see how cool it is Zeppelin once we get to the demo. So actually, I'll jump on it. So the easiest way to start with Zeppelin is you can download it, and once you download it, you can start. Okay. We talked about Embody. If you have a Hadoop cluster, the first thing this is how you interact with your cluster as an admin. You connect to Embody, and Embody manages your services and everything on it. And because Embody is open source, anybody can add their software to start it up or shut it down from Embody. So you can see here, there's almost the whole animal zoo stuff, zookeeper, school, big, hive, HBase, whatever you name it. And plus Nifi, we mentioned Nifi, so Nifi could be a service here, and Spark that comes out of the box, and this is Zeppelin notebooks. So when I have Zeppelin here, and usually I believe when you download the sandbox now, Zeppelin comes part of it. We work with it with something called Embody Views. So if you want to drop files into HDFS, into Hadoop, you'll probably do it from HDFS files. You browse the whatever file you want, create a directory, upload it. If you want to work with Hive as a SQL only, you do it here. Even Nifi, you can do it from the Embodied Views. Big store, whatever you name it now. My use case here is Zeppelin. So this is the first thing you see when you connect to Zeppelin. What you have is a slick interface. You create your own notebooks here, and this is a cool page which has all the interpreters on it. When you want to write your notebook in Scala, you don't have even to say this because by default it's Scala. So what happens? You tell Zeppelin this is where Spark is installed, and you tell Zeppelin where Spark is installed, which is Spark home over here. So what happens every time you start Zeppelin, it goes back to Spark and create that Spark context that we talked about in the back. So you don't have to go manually and I want to start up my SC, because Zeppelin does it in the back. So once that happens, you can go up here and instead of, for example, you want to limit the memory for your own Zeppelin, you want to say, I only want to use 512 meg. When it starts the Spark context, it will make sure that you're only using 512 meg out of the memory for Spark. Now this is if you're a user. If you're enterprise, you don't do that because we don't allow users to specify how much memory they want. We as administrator tell them you're not allowed to use more than X amount of memory, and that's it. So this is how you work out with Zeppelin. So back to the interpreters. If you want to do anything with Python, we use what we call PySpark, which is the Scala interpreter in Spark. Or if you want to use SQL directly, if you want to add any library for dependencies, a CSV reader or anything like that. Plus, you can add a lot of new interpreters. So this is only the Spark interpreter stuff. If we go to down, so you can do just comments, Angular. You want to talk to the Linux directly from here, SH. You want to utilize Hive. You don't want to utilize Spark. Tajo, Flink. Anybody heard about Flink here? So kind of like Flink, they're mimicking Spark and everything. Lens, Ignite, Cassandra, Geo, which I have no idea about it. vSQL, so if you have Hawk or any Postgres. Phoenix, anybody knows HBase or Phoenix? So HBase is the NoSQL. HBase is a very interesting database. This is when people ask, how can I do sub-millisecond responses on lookups, for example. We do it on HBase. Okay, how can I have a SQL skin on top of HBase? We do it with what we call Phoenix here. Kylan came out of eBay, and eBay reached 20 billion or something records on their Hive tables on a single table, and they needed a way to cube it. Rather than doing every select query and go through the whole records again over and over. So Kylan came out. Cool. So once I have that, what I just do, if I want to create a new notebook, I will just say, okay, I'm creating notebook 1 and create it, and I'm ready. So I'll go to it, and here you'll just say, okay, I want to write SQL, for example, and then do select whatever you want from the table you want blank. So I'll show you some notebooks that we have already prepared in the past. Let me go through them one by one, because every notebook shows another case. So here I'm doing kind of like shell scripting. So that was the earthquake database. My colleagues in the US had created that, was showing how the magnitude of different earthquakes are happening, which part of the world that was happening the most, what time of the day was mainly happening. So if you can see here, this is mainly SQL stuff on the data set that I've loaded on top. I'll show you more on how I'm loading data set and stuff like that. But at the end of the day, this is the visualization. So even on my SQL query here, you can change the visualization the way you want it. And let me show you how does it look like. I guess eventually here it shows you all the hot. I like this screen. It makes my notebooks look really nice. So yeah, here for example, these are the hot areas that you get the earthquakes on. So it's pretty cool, pretty slick, pretty easy to work with. If I go to more kind of the Spark SQL example, yeah, I wanted to show you the Australian stuff. So here we loaded the data, and probably a lot of you heard of data.gov.au. You can grab a lot of data sets from there. It's a pretty cool place to grab data and read it. So we have, one of the things. So I've done a cool one. I'll probably see if I have it on driving and drinking, which was pretty bad. But it shows you what are the number of fatalities we get per week because of alcohol and driving, and what is the most day, which is obviously Saturday and Sunday, and what time of the year, and what kind of. There's a lot of, like, the police data set is pretty rich. They have a lot of stuff in there. What the age of the person, is it collision with a fixed object or with another car? So it was pretty cool. But, so this one was from, I believe it was Medicare. No, it wasn't Medicare. It was the health expenditure in data.gov that I used. I was showing, and it's mainly a table, a CSV table that I was loading in Spark and doing, okay, how many states is spending the most? What is our spending per year? Where is our taxpayer money is going from healthcare expenditures? So you can see public hospitals are getting the most of the funds. So yeah, it was a pretty cool way to understand and see how it works. And here you can even create all the tables from here once you load it. Once you load the file, which happens here. So I'm loading the file here. Yeah, we kind of want it to look very fancy, but it's much easier than that. Sources. So I guess this is the same one with, yeah, that's the same one with the data set, a little bit more stuff, the spending per billion, and that sort of stuff. Anyway, so, any questions on Zeppelin, by the way? Any questions on Zeppelin? Oh, good. Okay, cool. I'll continue on. How much time have we spent in time?
Okay. 10 minutes.
10 minutes. Okay. Let me show you this cool tool. So there's a lot. Like usually, I need 3-4 meetups to cover a lot of stuff and a lot of cool tools in the market. The open source stuff. CloudBreak. Anybody heard of CloudBreak? Anybody try to set up a Hadoop cluster? Cool. How long did that take?
We're still doing it.
A few days to get it right.
A few days to get it right. What if I tell you can get it right in half an hour? Using a cloud.
Yeah.
That would be cool, right? So, CloudBreak is another company that Hortonworks acquired in the last year. And the main reason for acquiring them, because they were closed source, so we bought them. We open sourced the company called Sequence IQ. So CloudBreak is now completely open sourced, and that means you can download it, you can work on it right now. You can either host it in your own company, so you can create a virtual machine or a PC with CloudBreak running on it, and it orchestrates. It's kind of like the Puppet for Hadoop. So I'm not gonna. I want to show you a new demo because this is always nicer. if I go here and I go, so you can do this at home, you can do this at your work, you can do whatever you want. So go to cloudbreak.sequenceiq.com. You create a login. I have mine already. So why? Because I want to show you what we have done. We have something called launch. Right. So I'm going to sign in. And if you ever thought, how am I going to create that cluster? I don't want to go through 50-page at least of documentation and do stuff. And I already have an OpenStack on-premise, for example, that I want to use. You have your own storage and it's running OpenStack on-prem, or you already have a cloud and you just want to test stuff on the cloud and see if it's going to work out or not. So what we do, the first thing is we go and do a manage credentials. So you can see here, I have Ned AWS. This is something that my company gives me, and I have Azure, and I could have an OpenStack as well for on-premise installation. So this is where we create the credentials. So if we say create credential, you're actually giving. So these are the options. You have the AWS, Azure, Google Cloud, or OpenStack for on-premise. So what's happening is you're creating a user, and that user got the access to the cloud, and it goes on your behalf and does all the work that you need to do based on Docker containers. So let's say I already have my SE, I already have my credential, and I want to create a cluster. Okay, somebody can time it, and you can see how we do this. I can say this is my SA cluster, and I want to have it in Sydney, and yes, send me an email when the cluster is ready. I create the network, I'm using the default stuff, I don't want to enable security for that. And I choose a blueprint. A blueprint is, that saves at least 1 week out of your work. What if you have a template for a Hadoop cluster? What if you can have different templates and you can reuse these templates based on the needs? You don't want to have a fully blown Hadoop cluster, you just want something to use Spark, for example. So you choose a blueprint that we have created for you, basic templates to start with, and you can configure that and modify it later on and save it so you can reuse it later on. So you can have a multi-node, small Spark cluster, streaming cluster, or a multi-node HDFS. So guess what? My favorite is the Spark cluster, and I will start with that. And here I say, okay, cool, how many masters do I want to have? I usually like to start with 2 masters, and I want to have 6 data nodes. You can keep the rest as default, and launch. So, the net account 2, okay, of course, because I have a problem with my credential. Let me choose another credential. Okay, there we go, launch. Alright, I am having this problem now, but that's embarrassing. Got it. So that was but this is default one. All right, second business. So here we go. The cluster now is being created. Once the cluster is finished, you'll get an email. Your cluster has been deployed. You've seen Ambari. You'll get a link. This is your Ambari access. You go there, you see all of these stuff configured and ready for you to work with. Now the coolest thing is once this is up, this is what I can do. Now, of course, now what's happening is going back to Amazon, it's creating all the instances on your behalf, it's doing all that dirty work that usually we spend a whole couple of days to do it. The cool thing is, when you have the cluster ready, which is not available now because it's being built, you can pause it. You can stop it. I don't want to be charged for your cloud at night. Can you pause it, and it will hibernate and shut down all the instances, and whenever you resume, it will bring everything up again. So this is cool. This is one of the coolest things that we have done, especially for discovery stuff. If you're doing that discovery on Spark on Hadoop, see how it works. And a lot of our customers use that on-premise on OpenStack. So we're working on VMware, on supporting VMware, but right now we support OpenStack 100%. So we'll keep this running. We'll see if it's going to finish in the next 15. Usually it takes anywhere between half an hour to 45 minutes, depending on how many minutes you get. Great. So CloudBreak is cool. Let's see what's next. I don't think I have a lot of time left. I want to keep some time for. So we've covered all of that. Okay, so we have Spotify. Everybody knows Spotify. So I don't know, that came in the wrong part, but when I was talking about the org, Spotify is using org now. And what I'm going to mention about the org is when you have your table on a CSV, you don't have to go through and scan the whole CSV for that table, because what we do, we take the metadata of that table, we put it on a header, so when you do a sum average count and sort of that, it comes out of the header and it's instanced. If you have what we call a normal table, external table, we have to do a full scan for the table to do a count, for example. So that's why it does make a difference. I'll put the slides on Meetup so you can go. There's a lot of stuff here that I haven't covered. This is what I told you about. If you want to explore what's there in Spark, go to I can't read it here. But anyways, it's Spark Dev or Spark Packages. I'll put that on the Meetup as well. You can see all the connectors that you can have in Spark and that sort of thing. Yeah, that was. So this is one of the very important tungsten features that was getting in 1.5. And now in 1.4 you have to turn it on. You have to turn it on manually, but in 1.5 it's on by default. So for the data science, this is in 1.5. This is a new algorithms being supported on the ML pipelines. And a lot of people say, oh, what about this, what about that, what about that? And yeah, Spark keeps on saying that it's coming, it's coming. The NF Labs. NF Labs is the company behind Zeppelin, by the way. They were in Korea, they moved to the Bay Area now, in San Francisco. So I was with them in Korea, we played football, and yeah, they kicked my ass. But it was a great day to have with these guys. So we bought ours down there in Zeppelin. So this is an old slide where we're saying ours is coming. Kerberos authentication is coming if you have LDAP and Active Directory and you want to integrate it. We have something called Zeppelin Gallery. You can go there and download a lot of templates like our notebooks so you can see how we work in that way. Eventually, yep, so this is what we're trying to get to eventually. And yeah. All right, that was a lot of material to cover in 45 minutes. No question. Spark, Zeppelin.
Is CloudWatch open source?
CloudBreak.
CloudBreak, yeah.
Open source. So we open sourced it 6 months ago.
Okay.
So you can download it, do whatever you want. And as I said, if you want support, talk to us.
Any other questions? I guess just one final question. There's a lot of information in there. What's the best way for people to come up to speed with Spark and learn it?
Right, so the best way to start with Spark, now you can always do the search and see where you want to learn it. I would definitely say go to download the sandbox from Hortonworks that already has Spark encapsulated in Hadoop. And we have labs and workshops. It starts from very simple stuff to more complicated stuff. Whether you're in the SQL part or the machine learning, there are different labs and workshops, and I can post that on the Meetup as well. As for, I'll put my details on the Meetup. If you had any question about any certain tool from what we have discussed today, just let me know and I'll flood you with information.
Will you put the slides?
Yes,
on
I'll
the
do.
Meetup?
Yeah, yes, I'll do that. And I am based in Melbourne. Hopefully I'll be more engaged with these meetups from now on. And yeah, I'm so happy being here in front of all of you. So thank you very much for having me.